Hi, my name's Avaneesh Rade, and I'm an undergraduate researcher here at the Pain Stress Lab run by Dr. Kolber. I'm excited to present to you my research experiment for the summer, testing pungency of capsaicinoid homologues using the behavioral eye-wipe assay. Now, in order to understand the purpose for doing this, we need to understand the rationale and clear up a couple of basic facts. First things first, let's understand what capsaicin is. It's a well-known molecule that's found in hot chili peppers, and it's actually what makes chili peppers spicy to us. It's also the active ingredient in capsaicin creams. It initially causes hyperalgesia when you apply this capsaicin cream to your skin, but then it produces the intended effect of pain relief, also known as analgesia. Now, the problem with capsaicin creams that are over the counter and sold today in many pharmacies is that they have high doses of capsaicin, which leads to irritable side effects for those who are applying this to their skin. Things such as redness, itching, and swelling in the area that's affected. So in collaboration with Young Biopharma, we isolated 5 novel capsaicinoid homologues with the intention of maximizing the analgesic effect while minimizing the pungent effect that a capsaicinoid homologue would have. And our goal in this experiment was to determine the pungency of YB compounds and compare them to capsaicin. So initially, we hypothesized that these capsaicinoid homologues would actually produce a less pungent effect than capsaicin. And in order to test this, we used the behavioral capsaicin eye-wipe assay. Now, this assay specifically had us create these compounds at various concentrations and do a 5 microliter drop of them into the left eye of a wild-type mouse, and then place that mouse into a plexiglass enclosure and record it with 2 high-speed slow motion cameras. Those videos were then later downloaded and then analyzed. And in a 0 to 1 minute and 0 to 2 minute bin, the number of eye wipes were counted for this mouse. Then when we take a look at the data, what it showed us was that when we look at the dose response curves, which is what's noted here with the eye wipes on the y-axis and the concentration, aka in milligrams per milliliter, it shows us that these YB compounds were all less pungent than capsaicin. But one important thing that we have to note is that YB16 was a lot less pungent than YB2 or YB11 when we compare it relative to capsaicin. So this shows us that YB compounds are less pungent than capsaicin. But how do we quantify that? And that's where the MPP and RPP scale come in. So MPP stands for moderate pain potency, and it basically means that it's the concentration needed to cause 10 eye wipes on average within 1 minute. Now, using MPP, we created RPP, or relative pain potency, which is an arbitrary numerical scale that actually measures the relative potency between capsaicin and the YB compounds, and actually allows us to determine the magnitude of pungency between these compounds. So the overall takeaways from the data that I just presented to you are, number 1, YB compounds are less pungent than capsaicin, as we saw both with the RPP scores and the dose response curves. In fact, YB2, 11, and 16 showed significantly less RPP values than that of capsaicin, which was set at a base of 100. And finally, the data shown to us can have us conclude that higher concentrations of YB compounds are actually needed to facilitate eye wiping behavior at the same rate of capsaicin. So in the future, we hope to isolate more of these compounds that can have an even lesser pungent effect than capsaicin, while also maximizing the analgesic effect that was determined in a later experiment, not shown on this list. Thank you.